In this second part of the parabola notes, we're going to look at what we were doing previously and work it out backwards. Instead of getting the equation and identifying the vertex, focus, and directrix, I will be giving you the vertex, focus, and directrix and asking you to write the equation instead. The first couple slides on this presentation are just the same slides we looked at yesterday with all of the rules and the graphs. We're just going to be using those for reference, and then I'll be jumping onto the fourth slide for the first example here. So my advice to you guys is still to start off by identifying whatever h, k, and p values you can from the given information. The vertex is a great coordinate to be given because that means immediately we know h and k. H is always the x-coordinate of the vertex, and k is always the y-coordinate of the vertex. Now for the second piece of information, we need to figure out what type of equation we have before I really apply any more rules or identify anything else out of this. So notice that from the vertex to the focus, it's the x-coordinate that is changing, not the y-coordinate. So if we were looking at the graphs, you would see here that it has to be one of these cases in the bottom because the vertex and the focus, these have the x-coordinate changing, but not the y-coordinate. So if it was the other way around, if it was the y-coordinate that was changing for the vertex and the focus, then it would have to be an up and down parabola like this. So for our specific example right now, we know that it's one of the y squared formulas. Now when we compare that to the rules we have over here, it makes it easy to identify what we need to do to find that missing number. So the focus is defined as h plus p, comma, k. So I can write h plus p is equal to 5. Because I just showed you guys that the x-coordinate of the focus for the left and right parabola is h plus p. So now if I solve this equation, because I know that h is equal to 3, so I could plug that in, then I would have 3 plus p equals 5, which means that p is equal to 2. So now coming back to the slide that has all of our rules, I'm still focusing on this column on the right. Now I know what the h, k, and p values are. Those are the only variables we actually want to plug in. We want to leave x and y as x and y. So now I have everything I need to plug in those other numbers, and I'll leave this up while I write it. So this is going to be y minus, we said k is equal to 4, so y minus 4 squared, and that will equal 4 times p. So since p is 2, 4 times 2 is 8. And then in parentheses, x minus, and we already found the h value, it was 3. So now we were able to start with some of the specific information like the vertex and the focus in this example, figure out h, p, and k from there, and then plug them back into the original equation instead of going backwards like we did yesterday. So that's it. That's the answer to example number 1. Okay, now here's another example. This time the vertex is 0, 0. So that lets me start off with h equals 0 and k equals 0. It seems like this should make the question easier, but I do see a lot of students get confused when those values are 0 because they lose track of where their parentheses should be and everything. Now the second important thing we need to do is figure out which formulas we should be looking at, which graphs. So based on the fact that my directrix is a y equals formula, let's look at how that would apply based on the graph or the equations. So from looking at the formulas, we can see that you only get a y equals directrix when it's a horizontal line for the directrix, which means that your parabola has to be going up and down because that's the line that the parabola avoids. If it was this case, it would have to be x equals for the formula. But our example is saying y equals, so I know it's got to be one of these. If we were doing that from looking at the equations, it'd be the same idea. The directrix for the x squared formulas show y equals a number. If it had been the other way around, it would have said x equals for a number. So based on the use of y equals for the directrix, I now know that I'm dealing with this equation. So I should have x minus something squared equals 4p, etc. So now let's look at what the value actually equals for y. In this case, it says that it's going to be k minus p. So if I come back over here and write k minus p equals -3, so k minus p being the rule for the directrix, I do know that k is equal to 0, so I can substitute that. And then the 0 part doesn't even matter. We can just ignore that, but I do need to get rid of this negative. So if I multiply both sides by -1, then I would have positive p equals 3. So now we've determined what our h, k, and p values are, which means we're ready to plug into the formula. And like I said before, now that we know we're working with the one on the left, I should have an x minus something squared. So in this case, my formula is going to say x minus h is 0. So I'm going to write this out for a second, but we'll simplify this afterwards. So x minus 0 squared equals 4 times p, and p is 3, so that's going to be 12, and then y minus k, which is again a 0. Now, since it's unnecessary to write plus or minus zeros, we can actually simplify this a little bit to just write this as x squared equals 12, and then you can think of it as distributing 12 times y, and the 12 times 0 part doesn't matter. So that's why some students get confused when h and k are equal to 0, because you don't see the whole thing. You don't see the h and the k values being subtracted there. It's just going to be x squared equals 12y. So that is our final answer for this second example. On this last example, there is an important rule we need to add in to what you guys can find based on the given information, and I have that written here as a hint. The vertex is always going to be exactly halfway between the focus and the directrix. So what I'm telling you is that if you're looking at the graph, when you have a y value for the directrix and you look at the y value for the focus, the vertex is going to be exactly in between them. So if this was a height of 4 and this was a height of 0, then this coordinate would be at a height of 2. The x value might change accordingly, but we can figure out exactly what the k value is based on it. Same thing happens for the left and right parabolas. If this one has an x value of 0 and this one has an x value of, say, 8, then the vertex, where the parabola actually kind of splits into the two different sides here, then that would be at a distance of 4. So looking at this one, we have a directrix. This one has the horizontal line at a height of -1, and then the focus is up at 3. So we're dealing with something that looks pretty similar to this graph. So we have a height of -1 and then a height of 3 for the focus, which means the vertex is going to be exactly halfway between at a height of 1. So I can say that k equals 1. Now the other nice thing to notice is that for the up and down parabola, in this case, our x-coordinate should be the same for both the focus and the vertex. So we just found what k equals, but they've essentially given us h. The h value does not change between these two coordinates. So since h is equal to -4 for the focus, that's still true for the vertex as well. And you could have also identified this from looking at the equations, because if you look at the focus and the vertex, you see how they both have an x-coordinate of h. That's why I knew that it was the same number for the other one as well. So now we have h and we have k. Our next piece of information that we need to use is the directrix here, which says y equals -1. So again, looking at the slide here, we know that the directrix is y equals k minus p. Well, we have y equals -1, so that means I can say k minus p equals -1. Since we already identified that k is 1, we can plug that in. And then I'm just going to solve this, subtract 1 from both sides, and then finally multiply both sides by -1. So now we have those three values we need to be able to write our equation for standard form of a parabola. We have h, k, and p. We just need to make sure that we use the correct formula for it. And again, we're just trying to be consistent here. Since we were using the formulas on the left-hand side, I keep using this setup. So my rule is going to be x minus, and then the h rule was -4, so don't forget that subtracting a negative is the same as adding. And then this equals 4 times p. We said p is 2, so that's going to come out to an 8. And then y minus k. So that's our final answer. We've determined the equation for the parabola based on the given information focus, and directrix. And that's actually it for the notes. So you will see a variety of them giving you different information to start with. Just remember these rules. Remember to keep looking back at your formulas. The graphs are especially helpful for kind of visualizing some of the information, but it's probably the equations you'll need to use more for actually doing your plugging in and solving. So thanks for watching, guys.